Hello, guys. This is Prime Concept. Now, we are here to introduce a new topic, a very important topic. When you are studying the course electromagnetism, the very first topic you need to understand is the topic electrostatics. So, we're going to do an introduction to this topic in this video and then build on this concept in subsequent videos. And what is electrostatics? Now, if you watch this topic can actually be broken into two parts. One is electro, which can mean electron. An electron talks about charges. And then you have statics. Whenever you hear statics, statics talks about something that is stationary. So if you put the both of them together, it simply means that electrostatics is the study of charges that are stationary or charges that are static or charges that are moving very slowly. That is electrostatics. The study of stationary charges or the study of static charges or the study of charges that are moving very slowly. Of course, when something is moving very slowly, it can be assumed that that thing is actually stationary relative to something that is very fast, right? So that is the concept electrostatics. So electrostatics studies charges. So if this topic or this concept studies charge, it means that before you can go further or proceed with this topic, you would really need to understand what charge is and some of the properties of charges. And what is an electric charge? An electric charge is an intrinsic property of matter. That is to say, is a property that is within every matter that makes it possible for that particle to experience an attraction or repulsion in an electric field. That is an electric charge. An electric charge is an intrinsic property within matter that makes it possible for that particular substance or particle to experience an attraction or repulsion whenever it is around an electric field. So, a simple way for you to understand what an electric charge is to relate it with, say, a magnetic field. Let's say we have a magnet. Say this is a magnet. Say this is a magnet. My marker is a magnet, and my pen here is a nail. So if I have this, now this is a magnet. If I bring this nail close, there's a region to which I'll bring this nail, it will experience an attraction, right? So that property within this that makes it to experience an attraction is what you know as your magnetic property, right? If I bring a wood close to this, there will be no attraction because this in itself does not have that intrinsic property that makes it experience attraction with a magnetic field. So that is exactly what we mean by electric charge, the property that is possessed by matter that makes it possible such that whenever you bring it close to an electric field, it will experience either attraction or repulsion. That is what we mean by electric charge. And electric charge is usually denoted by the symbol Q. Some books would use small q, some books would use capital Q. So this is the symbol for electric charge. So electric charge is denoted with the symbol Q. And electric charge is measured in the unit of Coulomb. So the unit is Coulomb, which is denoted with capital C. So charge is measured in Coulomb. Now we want to look next into the properties of charge. So charge would have so many properties and we need to know them. And properties of charge. What is one property of charge we need to know? One and first property of charge you should know is that charge is a scalar quantity. Electric charge is a scalar quantity. So when you say electric charge is scalar, it simply means it does not have direction. So when you're adding up electric charge, you're adding up two charges. You don't consider their direction, so you just do direct addition for it. So electric charge is a scalar quantity. You can add them up directly. That is what it means. You can have Q1 plus Q2 plus Q3 and so on without bothering about direction. Now, another property you should know, number two, is that electric charge can either be positive or negative. Electric charges can either be what? Positive or negative. And since electric charge can either be positive or negative, it simply means that you would have two kinds of force for electric charge, right? So like charges would always repel each other, unlike charges would attract each other. Like charges, what do we mean by like charges? Say you have positive and positive, it will experience repulsion. If you have negative, negative, it will experience repulsion because they are like charges. But when you have unlike charges, positive and negative, or negative and positive, it will experience what? Attraction. So that is another property you should know. Then another one you should know, number three, is that electric charge is quantized. Electric charge is what? Quantized. So when you say electric charge is quantized, it simply means that electric charge are integral multiples of the charge of an electron. Electric charge are integral multiples of charge of an electron. That is to say, Q is going to be N times the charge of an electron. So you can have 2E, you can have 1E, you can have 3E, you can have 0.5E because 0.5 is not an integer. So electric charge is quantized. So it comes in certain whole number, which is denoted by N. Now that is it. Number four, another property we should know is that electric charge obeys the law of conservation. Electric charge follows the law of conservation of charge. That is to say, electric charge is conserved. And what does the law of conservation of charge say? The law of conservation of charge simply says that electric charge can neither be created nor destroyed, but can be transferred from one body or from one point to another. That is the law of conservation of charge. And electric charge follows that, right? Yes. So we have some other properties for electric charge, right? Now, another property you should also know is that electric charge always constantly radiates energy from them. So it will always radiate energy from electric charge would always radiate energy from itself. So these are properties you should know. So we'll have so many more, but we'll stop here so that we can move further, right? Now, there's a law, a basic law that governs electrostatics, and that law is what we know as Coulomb's law, Coulomb's law of electrostatics. So that is the law that governs electrostatics. And what does Coulomb's law say? What does Coulomb's law say? Coulomb's law says that the force of attraction or repulsion between any two charges is proportional to the product of the charges and inversely proportional to the square of the distance between the charges. I would repeat. It says that the magnitude of the force of attraction or repulsion between any two charges is proportional to the product of the charges and inversely proportional to the square of the distance separating the charges. So that is Coulomb's law. And mathematically, we can say that F, which is force of attraction or repulsion, the magnitude, is proportional to the product of the charges. Say we have two charges, Q1 and Q2. So the force is proportional to the product of these charges, and then inversely proportional to the square of the distance separating them. So if you put this together, you would get that F is equal to, when you remove the proportionality sign, you introduce a constant. So F is equal to K, Q1, Q2, all over R squared. So this is Coulomb's law mathematically. F equals this, where K is a constant, right? K is a constant, and K is given as 1 over 4 pi epsilon naught. So this is K. Now, when you evaluate this quantity, it can be evaluated. You know the value of epsilon, 8.85 times 10 to the power minus 12. So if you evaluate this quantity, it's going to give us approximately 9.0 times 10 to the power 9. And what is the unit of K? The unit of K is Newton meter square per coulomb square. That is the unit of K. So this is Coulomb's law mathematically in scalar form. So this force just gives us the magnitude of Coulomb's force or electrostatic force. So this is Coulomb's law. Now we're going to proceed and solve a few problems, right? Now, this law can either be called this force, sorry, can either be called Coulomb's force, or you can call it electric force, or you can call it electrostatic force. Now, let me still mention that in nature there are three forces that nature gives us, and one of those forces is what we call electric force or electrostatic force. Then you have another force that nature gives. So that is to say, these forces exist naturally. Another force is your nuclear force. That is a force that exists in the nucleus of an atom. Then another force that nature gives us is what you call what? Gravitational force. So these are three forces that we have naturally: electric force, the gravitational force, and the nuclear force. Now, one thing you should also know is that the electric force and the gravitational force have one common relationship. And what is that common relationship? Electric force and gravitational force, they obey the inverse square law. Electric force and gravitational force obey the what? Inverse square law, while the nuclear force does not obey the inverse square law. Now, how do we know and what do we mean by inverse square law? Any quantity, any mathematical relationship where you always have that quantity is inversely related to square of distance, then you say that quantity follows the inverse square law. So this electric force related to inversely related to square of distance, so it follows the inverse square law. Don't forget, it's very important, right? Now somebody may ask, amongst these three forces that nature gives us, which one of them is the strongest? Of course, the strongest of these three forces is your nuclear force, followed by your electric force, and then your gravitational force. So don't forget, take note of these points. Now let's consider a simple problem under here. Now we're going to advance this concept in our further videos, because what we have just seen is just the magnitude of Coulomb's force. In our next video, we'll be learning Coulomb's force in vector form, which is too important that anybody would want to miss, right? Let's take a simple problem here and then we'll continue. Now we have a problem. The question says two similar charges repel each other with a force. Two similar charges repel each other with a force of 4 times 10 to the power minus 5 Newton. Find their distance of separation. If the charge is 1 microcoulomb. So this is what we have. So we're going to solve this very simple problem. Now we have two similar charges. That is to say, Q1 and Q2 are similar. And they told us that if the charge is 1 microcoulomb, so it simply means that Q1 is 1. Remember, micro means 10 raised to the power minus 6. So 1 times 10 to the power minus 6. Q2 is also similar, so which is also 1 times 10 to the power minus 6 coulomb. So we have Q1 and Q2 because they are similar charges. Now, with a force, so they gave us the force F. F equals 4 times 10 to the power minus 5 Newton. So the question says find their distance of separation. So we're looking for R in this question. We want to find R. Now, to find R, we recall the formula for Coulomb's force. So the formula says F equals K, Q1, Q2 over R squared. So since I'm looking for R, I'm going to make it the subject. So I'm going to push R here and take F down. So I would have that R square is going to be KQ1 Q2 divided by F, right? Automatically my R is going to be the square root. So let's go direct. K has a value I gave you already. K is 9 times 10 to the power 9. 10 times Q1. What is my Q1? Okay, 1 times 10 to the power minus 6. What is my Q2? Q2 is 1 times 10 to the power minus 6. All divided by my F. What is my F? 4 times 10 to the power minus 5. So this is what I have. So if I punch this, I would have 9 times 1 times 1 is 9. So I have square root of 9 times 10 to the power. So minus 6 is minus 12. So 9 minus 12 is minus 3. So minus 3 divided by 4 times 10 to the power minus 5. So if I solve this, I would have 9 divided by 4 is 4. It's 2.25. So R is going to be square root of 2.25 times 10 to the power. When this power comes up, it becomes plus. So you have 5 minus 3, which is 2. So you have this. So if you punch this, 1, 2. So square root of 225. This is simply 225 actually. So square root of 225 is going to be 15. So we'll have 15 meters. So we'll have 15 meters, and this is our answer. All right. I believe this concept is very simple and very clear. Thanks. Now, I think I should add one more example to this problem. Now, another problem we can see here is, let me give another one. If the force between two charges is doubled, what will the distance be? What will the distance be? So if the force between two charges is doubled, what will the distance be? So this is a very simple question of comparison. Now it means that we are comparing force and distance, right? Now if you check Coulomb's law simply tells you that force is inversely related to the square of the distance. So it means that F is inversely proportional to R squared. So if you solve this, you're going to have F1 R1 squared equals F2 R2 squared. So we're looking for R2, that is the distance, the new distance, if the force F2 is double. That is to say that F2 is 2 times F1. So if I solve, I would have F1 initial distance R2, and then they say if the force F2 is double, that is to say F2 is 2 times F1, and then what will the distance R2 be? So simple, from here you can see, you would see clearly that F would fizzle F. So if I make R2 the subject, I would have that R2 squared is going to give me R1 squared divided by what? 2. And then if you solve this to get R2, you have that R2 is going to be R1 over square root of 2. So this is what you're going to have. So it means that if the force is doubled, then the distance is going to be 1 over root 2 times R1. So this is what your answer is going to be, 1 over root 2 times R1. All right, I believe this is clear. Do subscribe to my channel. I'll be dropping more videos on Coulomb's law or electrostatics. In my next video, we'll be advancing into vector form of Coulomb's law. Very important part of Coulomb's law. I'll be demystifying the concept there. So do share my video with your friends so that they can also benefit Remember, this is prime concept. Thank you.